All right. Hi, everyone. Hope you're having a great day or evening here in Europe. Hopefully, our this time is a little bit better for people in Europe. I know it's definitely a little bit late with the old time, so I think we'll try to do this going forward. So today, I thought it would be fun to do another one of these sessions where we work through doing a pull request together. We did one a couple weeks ago, but due to technical issues on my part, that did not get recorded, and I lost power on my laptop 45 minutes in or something. So I thought it would be fun to try to do that again and kind of have a version that we've got for posterity here. And I thought this one might also be fun because I think we've done a couple of these before, and they've always been pretty structured, I would say, of like, we're like, hey, there's this issue that exists in this repository. We're going to say we're going to work on this issue, and then we work on the issue, which is great, and is definitely one way that things go. But sometimes the other way they go is a little more organic, where that can come from maybe you as a user. You feel like, hey, this thing is not as good as it could be, and you've got an idea of how to make it better. Or particularly if you get a little bit more involved and you're kind of the library author, or even if you're not the author of the whole library, you're kind of taking responsibility for addressing issues that come up with a particular feature or piece of functionality. Having someone else come in and be like, hey, I had a question, or this thing isn't working for me. And maybe the first line of defense, so to speak, is, well, here's how you can do this thing, or you need to structure it this way. But then kind of taking that and thinking, well, is there a way that we could make it better where this person wouldn't have kind of needed to have that question, or this would have worked naturally for them? And I think that's what we're going to try to do a little bit today. It's, I guess, a little bit good timing. Normally I try to resolve issues in real time, which is great, but means that when it rolls around time for a Zymposium, I don't actually have like an issue for us to work through. But I think I actually have one from yesterday that's kind of an interesting one. So let me share my screen, and we'll kind of try to motivate it here. All right, so I got ZIO here. I'm just going to make this a little larger. And I'm going to start by just creating a little sample kind of example spec just to motivate this issue. This is going to be one that's involving ZIO test here. Let's start this up. All right, so I'm just going to start by doing ZIO.all, do like object sample spec. Then spec defaults, just do the spec, screen sample spec. Just first make sure this works before we do anything else. Let me go to project. To the end. What's going on with the about test sample spec. Wait a minute, it's file here. Hopefully not too long. I should get like some background music here for this or something. Oh, and what do I? Oh, okay, I wasn't even using this. Okay, maybe I should not have my super duper level of linting settings on. But that's fine. Let's do that. Okay, so fine. So okay, so test is passing. That's fine. So here's kind of the like question that this user came with. So I think they were doing something with like ZIO JSON, and I'll just kind of create my own little example of this. So let's say we've got some JSON decoder here, and so it says, well, hey, if you have some string, you can decode it, and you're either Just right now, you're going to get a string error, or you're going to be able to decode it into this type A. And maybe they had a particular JSON encode that they were working with. So I'll just say like val my JSON, sorry, decoder. And maybe this is a JSON decoder of int. And it's going to this thing. And so fine. So let me just get the auto compilation going here. So I'm checking this out. Okay, so I had this thing. And so what they were looking to do is they were doing something like for, let's say, decoded int in my JSON decoder decode 42. They wanted to do something like yield assert true, decoded int equals 42. And if you look at this thing doesn't work. And admittedly, it doesn't give you the most user-friendly error messages, as this test constructor thing doesn't exist. But the basic answer that, like the first level answer that I give for doing this is like, hey, the way it works is you either put a ZIO inside this test or you put just a value. So if I didn't do this, if I just went back and I did assert true, whatever, 42 equals 42, that's totally fine. And if I do, so let's do something, let's say for n in what ZIO.succeed 42, I could do yield assert true n equals 42. Oh, now I actually do need my ZIO. And so that's totally fine as like a first level answer of like, okay, right, there are these two things we support. We don't just support any like arbitrary type. And if you do have this, it's pretty easy for you to put it into a ZIO if you wanted to kind of make this work. But you could also think, okay, that's fine. I mean, there's definitely like ways to do it, but it would be, again, it would be like nice if you could do this. This person doesn't seem to be doing anything like crazy here. It's kind of a understandable thing you might want to do. Of you kind of have things where your effect type, so to speak, is an either instead of a ZIO, right? Like this is kind of this domain of decoding. So you don't have ZIO effects here. Now, again, I could make this work by just doing ZIO dot from either here and kind of putting that all into the ZIO world. But should you really have to go into the ZIO world? And so what I was thinking is, well, maybe we should be able to support this, because actually this is probably something that you notice less. But I can even do something right now of I could do, let's say, for value in tref dot, let's say for ref in tref dot get, value in ref dot get, yield assert true value equals 0. And well, if I import ZIO.stm.all, okay, I really shouldn't disable my instance for this. You'll see that this works. And this is kind of interesting because this doesn't actually return a ZIO. It returns a STM transaction. So if we kind of say what the current state of play is, we say ordinary values are fine, ZIO values are fine, STM values are fine, but right now either values are not okay. And seems like maybe they could be okay, right? If we're already kind of accepting these values, it's not clear what would be like so different about these either values that they are something that we could support, even though we support these other values. Now, I would say here that I guess as we're going through this process of like doing this together, it's really good to do this type of thinking yourself sometimes, because I think oftentimes when you like have an issue, you've got a really valuable perspective because you're having this issue and like you're deep into it, right? You're deep into whatever your domain is of like this person is trying to test their JSON codecs and having an issue with it. So that's really like valuable insight that they have. But when you go to like submit a pull request or kind of make a change, one of the things that I'd really encourage you to do is also think about like the library author's perspective. So is this change going to kind of mess with anything else here? Like if I was being a little critical of this, maybe I would say, well, you know, this is like a little bit magical, right? Of like the test like works with all these types and like, does that make it like less clear to reason about? I don't think that's really true here because we already have like several different types we're supporting and things seem to work fine. And I think this one doesn't end up being used a ton just because people don't use STM as much as they use like ZIO ordinary values, but this one also seems to work fine. So I don't really think there's an issue of like why we shouldn't do this, but I would say it's like really worth like asking yourself that and like thinking about that and thinking about that as you're like structuring a change if you are making a change. Because sometimes what I do see is, you know, people have like a specific problem and they kind of put something out there that like solves that problem, but sometimes it like creates 10 other problems. And especially when someone's like put a bunch of effort into that, then that's not a great situation any way around of like that person feels like they've wasted their effort. And, you know, I want to help people get their stuff in, but I also don't want to like create other issues. So try to like internalize that like library author perspective a little bit as you also have your like user perspective of like, this thing isn't working if you're kind of trying to think about like how to approach like a problem or like, is it a problem that like we should change at the library level versus like, there's just a different way to do this thing. Okay, so that's kind of motivating the problem. I'm just gonna take 1 sec here. I'm just gonna go back to the Discord and just check in if there are any questions as we're going. Okay, so hopefully people are good. Okay, so let's so we got a couple of questions here. So one is, should we consider option value as well? Maybe so. I mean, my general attitude is like, take things one step at a time. So yeah, maybe we should do option value as well, but right now we don't do either values. And it seems like the either value is maybe a more common or useful case. And then we have this kind of question of like error messages. And like, yeah, the error message could be better, but I think it would be better if it just worked, right? Of like this STM thing, like, I think it makes a good amount of sense of, okay, like if we wanted to be super explicit, we could say, well, this is a transaction, right? This is an STM. And then I could do transaction.commit. That's like a more explicit way of now I'm turning into a ZIO by the time I commit it. But like, have I really gained anything by making the user like do these 2 steps? I kind of think not, right? It's kind of nicer if I can just do this. But you know, that's definitely something that like there's elements of subjectivity in these things. And so that's where I definitely like, again, encourage you to like think about that like library perspective of like, how are these things going to work overall? And like, okay, we can make this situation for like either work better. Are we doing it in a way that we're going to make anything else worse? And I think in this case we're not, but you know, we can have something. We can kind of debate that. Now, so Naveed's raising this question of like a wrong test accidentally passing. So I'm not sure that really is something that should be a concern for us. So like, let's go back to this and let's say that this did compile. So, I mean, and maybe Naveed, you want to like jump in here, but like, what would be a wrong test that was accidentally passing here? Well, what would that mean? And remember, we're already supporting even like, I mean, a really like core feature, I would say, of ZIO test is that we're supporting things like this. We're supporting this thing where this thing returns. Let me just put some types on these things so we see what these are. So we've got question. I'll just make this I know I need to bring back my ZIO. So we've got this thing that's a ZIO that, okay, well, IntelliJ is not, or VS Code is not working for me. But we got this thing, it's a ZIO that returns a test result. We got this thing that is a test result. We've got this thing that's a either that has a test result inside it. We got this thing that has an STM that has a test result inside it. So yeah, I guess I can see your point a little bit that you could also, like if we go back to, let me get back to, choose the actual example. This one here. So yeah, if I wanted to, I could do val my either is equal to, say, this thing. And then I could do assert true, my either is right 42. You can definitely, put all sorts of used imports. So you definitely could do this, but this may be, and again, there's some subjectivity here. This feels a little bit to me like that case where we had the like, transaction, right? And we had to do the like, we had to commit the transaction, and then we had to, so it feels like it's creating a little bit more boilerplate here. And I don't really see how you do something unintentionally that you don't want to do here. So if I go back to like this, this seems pretty readable here. And like, I don't know what you would be writing with this where like, this is not doing what you want it to do, right? I mean, these, you've got an int here, you're making an assertion about this int, like that seems to make sense. You're gonna fail if it fails. Now, clearly if you wanna do some other things, if you wanna like make an assertion that it's like the left instead, you're gonna have to use some operator that's like gonna flip this around. But again, that's the same thing that you do with ZIO. So at least I'm putting it out there that this kind of makes sense to me. But yeah, it's definitely like something you can think about. And I think this actually gets to kind of one of my other like suggestions here of, I think especially if you're not like kind of actively like contributing to the library in the thick of things, and oftentimes even if you are, open an issue before you do a pull request, because yeah, it could be the case. I mean, I think in this case, we're gonna just work through this because we're gonna work through it. It'll be kind of something fun we'll do together. But to Naveed's point, I could submit a PR with this, and maybe John's like, yeah, I think this is too confusing for whatever reasons. And I think if you're kind of submitting the PR without having kind of done the issue first in discussion, you're doing a little bit like on spec. So just to kind of acknowledge you're gonna, if people do say, we don't want to do this for whatever reason, you're okay with like the fact that you may have quote unquote like wasted that work. And it's not really wasted because you're learning stuff from it and we're all exploring ideas, but just kind of be aware of that. Okay. So with that, I think we've spent a good amount of time here kind of maybe talking through the pros and cons a little bit, which is actually good and kind of a good thing to do in your head, because I think a lot of times like what you're doing is more important than kind of the actual doing of it. Because if you're kind of going in the wrong direction, then even though like when you do a bunch of work on your PR, like other people may not really like where it kind of goes. So like make sure you have the right direction first, or at least you feel like you have the right direction. You kind of willing to take the risk on it and then kind of start walking down that road. So there's another question about warnings about types matching. Yeah, so there is a warning about the types not matching here. So let me see if I can demonstrate that. Well, now I have this other issue. So let me do ZIO.mi there. Yeah, so if I try to compare unrelated types in here, I'm going to get this error message. So I think that also kind of supports the reasoning that like I don't think there's really something like dangerous about like supporting this either, if that it's going to like let you write some tests that would have different semantics than you think it would. But again, some of this is judgment, so maybe we'll come back and feel like this was a bad idea. But hopefully this is at least a fun exploration for us to do together. Okay, so I think we're far enough in that we should kind of say, okay, this is the course that we've set ourselves on. So we would like to get this code to compile here. Oh, well, not this code, but this code. This code. Okay, and so I think the best way to proceed here is to actually follow this this warning a little bit. And so it says it can't find this test constructor. And so let's look at this test constructor thing. So this uses some fairly fancy techniques here. So you'll see here, we've got like an abstract type member. We've got what's called a path dependent type here. And then this test constructor is almost like its own little typeclass, you could say. Well, not quite that, but it's an implicit. And you see there are a couple of instances of it. So there's this first one here that's called an assert constructor. Then there's a second one here that's called an assert ZIO constructor. And then you've got this third one here that's an assert STM constructor. And so if we look at these things, what they're all doing is they're saying they potentially require some environment and they take some input. And then there's going to be some output type that's going to be some type of spec that requires at least the environment, maybe requires more. And this is just any, and this is covariant. So basically this could end up being anything in the more refined version. And it has this one method that is basically like that test method that says, well, you give me a label and you give me an assertion, and I'm going to give you one of these specs. And so like if we look at this first one here, this most concrete one, what this is saying is in this case, the in type is just a test result and the out type is just a spec. And in this case, we're just going to take a label and we're going to take an assertion that produces a test result. And all we're going to do is we're going to call this test method. And let me see if I can get us to the right one here. test. This guy. And I'm going to do it by putting that result inside of a ZIO. So this one is actually going to kind of delegate to this one here. And this one says, well, in this case, my input is not just an A, not just a test result, but it's a ZIO that produces a test result. And in this case, my test is going to now have an environment type that's going to be the same environment type as a ZIO has, and it's going to have an error type that's the same error type as this ZIO has. And in this case, I'm going to call this much more specific method that's going to construct this thing. And then I've got this third method here, or this third instance, that's going to do STM transactions. And this one is also basically going to delegate back to this one here, because all it's going to do is it's going to call test and it's going to call commit. So it's going to turn this transaction into a ZIO workflow. So this one and this one are basically just pointing back to this one, and they're just doing a little bit of extra operations. So this one is putting the value inside of a ZIO. This one is committing the transaction so we get a ZIO. And then everything is ultimately going through this spec.test constructor here that's going to actually like do the work of capturing this thing, and ZIO test is then going to do everything it's going to do to like run this test and give us the result of that. And so it's also worth, as you kind of get into these like libraries, there are different aspects of their functionality, kind of asking like, why are things the way they are? And so in this case, I mean, this is a very advanced pattern of what we're doing here. And you see it has some disadvantages of like, you get these like error messages of like, you're missing this test constructor. You're like, okay, well, what am I going to do with a missing test constructor here? But what this pattern, which sometimes you might call it like the magnet pattern, can be useful for, is it can let you overload something while still having very good type inference. So like the natural way that we would write this is we would just have some different methods, right? We would just say, well, def test, and it would take a label and assertion that was a ZIO. And then we would have another one. Let's see if this will, that took transaction to STM, right? We would just have a bunch of different methods like this. But when we do that, we end up running into a couple of issues. The first one is when we have these curried parameters, we're going to get an error from the Scala compiler when the first parameter is the same, even when the other parameters are different. We can get around that by using this like partial application trick, where basically this first thing would return a test constructor, and then it would have overloads for these three different things. But when we do that, we find that we've got a couple of problems. So one is we've got this like, well, actually the main problem here is just around type inference, that because we have these overloads, whenever something gets overloaded, the Scala compiler is generally not as good at inferring the types. And so I think we tried this at one point, and basically like you just got like, you know, we have a huge internal test suite, and we got like all sorts of cases where types are not being inferred. And if we have that, then our users are going to have that. So that's not going to be good for anyone here. So that's kind of what we get out of this. And then we're using this prioritization to create a very clear hierarchy between these different instances. And I think Naveed raised the point, like, do we really need this for some of these? Like these two seem like it's always one or the other. I think if we know this is a test result, then we kind of know that it's not a ZIO, but I'm not sure the compiler is going to know that. So, yeah, could we potentially simplify that a little bit? Maybe, but it also doesn't do us any harm to keep these separate, and it creates a very clear hierarchy where it's always going to try to apply this first, and then this, and then this. So we're never going to get a ambiguous implicits issue. So if we want to get this working for ourselves, I guess another bit of advice I have as we do these is like try to kind of think about making your changes like consistent with the code in the rest of the library, right? So that like you're kind of adding to the painting versus just like blowing up the painting. So here, if I said, okay, well, like we've kind of got this pattern of like we've got this test constructor thing, we've got these different instances, we're prioritizing them. So why don't I create another one here? And I guess I'll call this the assert either constructor. And so I don't have any environment type. I have an error type, I have a value type. And so now this thing is going to take something and it's going to give me, and here also sometimes it's good to just like look at the prior art and say like, okay, this one doesn't have an environment type, so I'll have an any that goes here. And then this thing, instead of being an STM, is going to be an either. And then this thing is going to be an any, but I'll still have an E here. This one's kind of unique among the ones I have in that it has an error type, but it doesn't have an environment type. And so then this will be any, either, EA. And so my out type is not going to require any environment, but it'll fail with this error. And my assertion now is going to be an either. And my spec is going to have any here. And so I can, again, kind of follow the pattern of, like we said, like the ZIO one is like the most basic one of everything kind of ultimately ends up here, and we need to put everything into a ZIO. So like we had to put this into a ZIO, we commit this to get a ZIO. So here, I think I could just use that ZIO dot from either assertion. And so now I've actually got my example compiling here. And the other thing that's kind of nice about this is we can even do this more broadly, but I could go back to like project root here and I could do like compile JVM. And this is going to compile all the tests for like everything in ZIO. And what I think we're going to find, which is nice about this and is important, is we haven't broken anything else. We can verify by actually running the test, but I think in this case, if we had broken something, we would be seeing it by something not compiling. So that's like one of the nice things about this technique is we can see it lets us add these in this very like targeted way where we're not messing up anything else we're doing by adding these. So, okay, this seems relatively nice. Now, you know, if we're being good people who are doing a pull request in addition to just doing the feature, we should do a test for the feature. So I guess another thing that is sometimes not as easy as one would like it to be, but I would recommend is like try to find where the related tests for something already are. So you're not just you know, kind of adding something in a totally different place and things get scattered out. But I think I've obviously got a little bit of a head start here because I've worked with this library a lot, though I don't know if I remember everything. So let me search here for, okay, so here we go. So yeah, so you can see here, we've got a couple of tests related to this. We had one that we wanted to make sure we could work with scopes. And then we have one specific around this STM functionality. So let's add another test here and maybe we'll call this like either values can be tested. And so we could have a similar pattern. So this could be write hello STM transaction. And right now, I guess here we just wanted to really make sure it's compiled, but if we wanted to, we could have something more specific here. Let me go back to Zymposium. Do like test only, ZIO test. Make sure this actually works. And if we wanted, we could make these a little more specific here, or we could add another test. So our expectation would be if I do this, then this should fail. And so let me run this again. And we see that this does fail. I guess I really should update this message. Hello from an either. And then I can actually use the test aspect, like this failing one, to assert this thing does fail. And so now I've got some tests for this functionality. If we wanted to do a little bit more, we could potentially do the same thing with the option thing. Wanted to take, I think Juan made that point earlier. So let's maybe play with that. So we could call this like a certain option constructor. And so in this case, we're not going to have any E. We're going to have an option A. And now this is going to need to fail with some type. And we could either use like the unit type. That's probably the most idiomatic. In some cases in ZIO, we've used none.type here. I don't think that's really necessary for this. Oh, that's going to be, this is going to be unit. And this would be option A. This is unit. Okay. Option A. And then this could be ZIO.option. This might actually return the none type, so maybe I'll end up changing that. But let's. Oh, and there is no unit here. And let's see. Yes, so they did this as option nothing instead, so I think that's fine. So let's just change this. And now, if we wanted to, we could have another. Let me just go back here. Let me do test. Option test. And say for like n and sum 42. You know, assert true and false 42. And now this should work as well. Another thing we could look at here is, I think there's one thing, another thing you sometimes want to think about is, as you're kind of making a change, what other changes do you need to have consistency? Because people, I think, really like a consistent API. And so like and there's another one where definitely like you benefit from having worked with the library more. But so one thing that I think comes up here, let's see. I think we have another thing. It's kind of like the test constructor, but it's called the check constructor. And this is basically what you use within property-based tests. And you can see we have the same functionality here. We're within a property-based test. So this would be like test property-based test. And then I would do like check And so this is just where it's an ordinary value. I can also do it where it's a ZIO. So I could do like for n plus x in ZIO dot exceed n yield switcher x equals 42. This is not going to be true, right? Because it's just any integer. But so this will work. I think almost that. Let's see, open this here. And I think I need 0 again. And this should just be int. So this will work, but if I make this be right, this is not going to work because I'm going to get a similar message. I don't have a check constructor here. So I could do the same thing here and kind of just apply that same logic. So I see there's a question from Juan of could we do the same thing with iterables and use a for each? Potentially. So I think to do that, we need to not only use a for each, but so if we think about an example here, so that means we're going to have a whole list of assertions. And then we're going to need to not only do the for each to get them all out of whatever the effect is, but then we're also going to need to combine them all together, presumably with and, though you could also combine them with or. I think there also just might be a trade-off there of I think that might be a little bit less valuable in terms of ergonomics of all of these are kind of supporting the for comprehension. Though I mean, I guess if we let's play with this a little bit. So we could have list example. And so we could have something like for n in list 1, 2, 3, 4, 5, yield, insert true, and is greater than 0. It's an interesting one. I mean, I think that maybe goes a little bit to that like question about magic here of like you could definitely implement this. I could see it being useful in some situations. I worry a little bit maybe that it goes a little bit too far in the magic, but there's definitely subjectivity here. So this is kind of another thing you could consider doing. And I could definitely see this being useful in some situations, though I would also kind of wonder here, is this just better written as a property-based chest? So this could also be like gen dot iterable 5 and then here, we can do that, or we could do the assert true. So definitely trade-offs in API design and kind of things to think about here. Let's see what. Oh, this is the ZIO again. Right, that's fine now. But we could if we wanted. All right, so any questions about this? Either about kind of this specific domain or like some of these like ideas we've been talking about of if you want to like submit your own pull request or issue, like things to think about. All right, well, hopefully this was helpful. So I'll do a little bit of cleanup on this, and then I'll push something up here. But I think maybe one of the things you see here is like a lot of times the PRs don't necessarily have to be that large. I mean, if you're implementing whole new features, then they can be very large. But a lot of times, especially when you're working with an existing library, like smaller is better. Sometimes I've done these as like one line PRs, but like kind of thinking about like what you want to do and what the trade-offs that are involved, I think is really helpful there. So like it's the ready, aim, fire versus ready, fire, aim. Okay, well, I'm going to give like 1 or 2 more minutes here just for anyone to ask any questions they want to about either this or anything else. We've got a little bit of extra time. But yeah, hopefully this was fun and kind of, yeah, you see there's no magic here. And also sometimes there aren't, sometimes there are wrong answers, but sometimes there aren't right answers. They're just trade-offs. And, you kind of try to think of the trade-offs that make sense. Yeah, like definitely keep, I know a bunch of you here have been really active in both contributing to issues as well as raising issues, and definitely like keep doing that. Think about that like library author perspective, and just yeah, get involved yourself. It doesn't have to be hard to do one of these pull requests. And I mean, I'm definitely around, John's around. There are lots of other contributors depending on the library you're working with. Okay. All right. So Juan is catching me because he asked me a question on Discord and I did not get around to answering it. So let me answer this question. So let me just save this. I'm gonna stash this. I'll call this work on either assertions. Okay, so Juan's question is, if I go to fiber ref and I make this here, you'll see that this involves a scope. And so his question is, why does this involve a scope? And one way to think about that is a scope indicates that something requires some type of finalization. So one way to kind of follow that through is to see, okay, well, what kind of finalization is it doing here? And so this is calling this make with, which let me see if I can find it. Yeah, make with. Okay, and here we see where the scope is coming from because we're calling this acquire release method here. And that introduces a scope because it says basically do this first thing and then do this thing when we're done. And so if you look at this, our initial thing is we're creating the ref, and then we're basically just updating it with the identity function just so the runtime gets the initial value of the ref. And then our finalizer, which is kind of why we need the scope, is deleting the fiber ref. And so if we go and we look at what it means to delete a fiber ref, it just means to basically delete the fiber ref. And so the answer for this one is that when we create a fiber ref, we're creating some piece of state that is going to be kept around for the life of the fiber. And most of the time, that's totally fine because we kind of want that to be around. But if we have long-running computations, it can actually create some issues for us. So imagine, like, let's say we're looking at ZIO tests. Let's go back to one of these like specs here. So the spec is a whole bunch of tests that are just being run one after the other. And there are different ways that you can run a test. You can run them parallel or sequentially. But let's assume we're running them sequentially here. So that means we're running this, and then on the same fiber, we're running this, and then on the same fiber, we're running this, and on the same fiber, we're running something else. And if we don't do any kind of cleaning up after ourselves, then that means if I created a fiber ref here, that fiber ref is still going to be around here. even though no one can interact with the fiber ref at this point because no one even has a reference to it at this point. And the fiber ref is still going to be around here. And so imagine you had some really long computation that was doing like 100,000 different things, and each one was creating a fiber ref. So then you're going to end up with like 99,999 dead fiber refs that you're dragging around with you, which is going to be bad for performance, bad for debugging, bad for a bunch of things. And so what this make method is saying is when you create the fiber ref, you create it within this scope that's also going to be responsible for deleting the fiber ref when you're done with it. So it's kind of a, I guess at least in the US, if you go to like the national parks, I think it's like, you know, leave no trace when you're like done with the national park. So it's a little bit of that same idea of we allocated something, we created this state, and we're done, we need to remove that state. And then so then you have a question of how do we know the scope is the same scope to which the fiber lifetime is bound? Well, this method says it takes a scope. And so when you call this method, that's going to be the scope you have. Now, you know, you may end up putting more than one thing in that scope, right? Because the scope gives you the ability to control when you close this. So if we create a simple example here, so the simplest thing I could do is I could do like, so here, this thing is going to require a scope. And this is going to be okay because ZIO provides an application level scope. So right now, this fiber ref is going to be created here and is going to be deleted at the end of this application. Now I could I could delete it in different places. So I could say, this is not going to be very useful, but I could say, hey, I want to create this fiber ref and then I immediately want to delete it by doing ZIO.scoped here. Or I could do, let's say I wanted to do fiber ref.make, and then what do I do? Fiber ref workflow could be something where I do like ref and fiber ref.make. Oops. And then I set 10, and then I get its result, and I yield its result. And then here, I could say for v in ZIO.scoped fiber ref workflow, and then I could say yield that, and I could do, maybe let's even do something else. Do v1. Well, let's just do so. So you can see here, we have this one workflow. We want to do something with the fiber ref, and we return the value. And then even though the fiber ref's been deleted by now, the value is still here. So the idea is you control the lifetime of it. And oftentimes it doesn't really matter because your fiber is not that long lived, but that's why they require a scope. So you don't end up leaking those fiber refs to other parts of your application. And so Juan says the fiber has its own life, and that's true. But again, let me go back to the example of the fibers doing 100,000 different things. And in one of those things, someone creates a fiber ref to do something that shouldn't leak to those other 99,000 things. So that's why it takes a scope. All right, any other questions here? Otherwise, we're probably at about time to wrap up. But again, thanks so much for kind of the questions. I think it was a really good discussion, especially kind of around the thing with the test constructor and kind of is it, is it a feature we should add? Is it not a feature we should add? I think that's like a really, again, good thing to keep in mind of like, sometimes I feel like people, can get frustrated where they're like, hey, I want to do this thing, and why can't I do this thing? But a lot of times, as I think you're saying, there are different considerations of like really what's going to create the best API and what's the right amount of kind of doing stuff for you, so you don't have to do boilerplatey stuff, but also not being too magical where you don't know what's going on. And some of them aren't things that have a mathematical answer, so we're all trying to figure it out together. But all right, well, thank you so much, and we'll be back next week. Take care, everyone.